Hello and thank you for watching. In this video we're going to go through some scalar product consequences and some examples. So in the previous video we defined the scalar product and looked at some of its properties. One of them was that if we have some vector dotted with another vector, this is equal to the magnitude of the two vectors multiplied together times cosine of the angle between them. So from this we can intuitively see that, okay, well, since cosine ranges from -1 to 1, then we can establish an inequality. So we can say, okay, if we take the magnitude of those two vectors dotted together, this is going to be less than or equal to the magnitude of these two vectors multiplied together. And this is, so we know that there's equality if this cosine theta is equal to 1, and this only happens when theta equals 0. So we're saying that equality if we have V and W collinear, which basically means that they lie on the same line. Okay, and we call this result the Cauchy-Schwarz inequality. Okay, I will give some examples soon, but firstly, one more thing I would like to introduce is saying that since we have this above here, we have that cosine of theta is equal to V and W dotted together over the product of the magnitudes. So therefore if we have V dotting with W equal to 0, this implies that we have theta equal to pi over 2. So what we're saying is that if the dot product of two vectors is equal to 0, they're orthogonal or perpendicular, if you will. Okay, now we're going to get on some examples of the scalar product and the notions we introduced here. So the first example, I'll just give an example of the scalar product itself, because I gave the definition but I did not give any examples in the last video. So firstly, I will say that if we have 1, 3 and 4 dotted with 6, 7 and 1, this is equal to 6 plus 21 plus 4, because we're just multiplying our components and then adding them together, which is equal to 31. Okay, next example, if you want to find the angle between, find angle between V and W given that V is equal to 6, 1, 1 and W is equal to 7, 2, 2. Okay, So you can pause the video and give it a go yourself if you'd like to. Okay, so when we find v dot w, this is equal to 42 plus 2 plus 2, which is equal to 46. If we find the magnitude of v, this is equal to square root of 36 plus 1 plus 1 equals square root of 38. If we have the magnitude of w, this is equal to 49 plus 4 plus 4, which is equal to square root of 57. And so we have that. And so we have that cosine of theta is equal to 46 over square root of 38 times the square root of 57, which is equal to 46 over 19 root 6. Okay, so as you can see, this did not give us a very nice answer, but I chose this on purpose just to show that we're not always going to get nice answers. So we have that the angle between them is equal to arc cos of 46 over 19 root 6. Okay, next example. Now I'm going to give an example of the Cauchy-Schwarz inequality as in its usage. Okay, so let's say we wanted to show that we have 3x plus 2y plus 6 being less than or equal to 7x x squared plus y squared plus 1. So, okay, this is actually a step question. If you don't know what step is, it's an admission exams for Cambridge Math for undergraduates applying for for an undergraduate course. Okay, so what we should notice here is, okay, we have this x squared plus y squared plus 1, and okay, so this is just the magnitude of x, y, and 1. So thinking, okay, we're going to need this in some way, but now we look at this, we have a 3 here, 2 here, a 6 here, so if we dot this with 3, 2, and 6, this is equal to 3x plus 2y plus 6. Okay, but this is less than less than or equal to the magnitude of those multiplied together, so is less than x squared plus y squared plus 1 multiplied by square root of 3 squared plus 2 squared plus 6 squared, which means that x, y, not z, 1 dotted with 3, 2, 6 is less than or equal to, well, this is square root 49, which is just 7. We have less than 7 x squared plus y squared plus 1, and therefore we get 3x plus 2y plus 6 being less than or equal to 7 times x squared plus y squared plus 1. Okay, nice. Next Cauchy-Schwarz example. I encourage the viewer to pause the video and try it themselves. Let's say we want to find maximum value of x plus 2y plus 3z given that x squared plus y squared plus z squared equals 1. Okay, so what we're thinking here is we're trying to maximize this, and okay, we're given that x squared plus y squared plus z squared is equal to 1. So our thoughts should be, okay, if we can bound this thing here with some inequality, then we can find the maximum value if this inequality has an equality case. So this x squared plus y squared plus z squared, we know that this is just the magnitude of x, y, and z, but also if we dot this with 1, 2, 3, we get this top part here. So this is less than or equal to x squared plus y squared plus z squared multiplied by square root of 1 plus 4 plus 9. So we have that x plus 2y plus 3z is less than or equal to, well, this is 1 as given here, and this is square root of 14. So we have that this is less than or equal to square root of 14 with equality when we have these to be bilinear, and so collinear, sorry. And so our maximum value of, hence the maximum value of x plus 2y plus 3z is square root 14. Thank you for watching. That's all for now. Hopefully this video helped you understand the scalar product a little bit better and its consequences. Bye bye.